So over past few videos, we have discussed about mainly two different control loop techniques. One is Ziegler-Nichols and another is direct synthesis. Now the question that obviously comes to our mind is which tuning technique to use and when, and what are the advantages and disadvantages of these tuning techniques. So let's begin. So direct synthesis technique is relatively new technique. Ziegler-Nichols technique is very old and proven. As I've told you, like it dates back to 1940. So it has been very prominent in the industry, I would say at least before at least 1990. Now, when Ziegler-Nichols was developed, that time mainly pneumatic instruments were there. So, and the Ziegler-Nichols technique is such that it provides more stable output in case of the pneumatic system. So, pneumatic system which contains the bellows, burden tubes, or baffles, nozzles. So, in that time, the tuning was done by adjusting a screw. Transmission line were pneumatic. Valves were not that precise, and these control loops needed a large surge of air pressure to overcome the line loss just to get the valve moving. So Ziegler-Nichols technique worked great for this system. But today's valves, controllers, transmitter, they are very precise. When the Ziegler-Nichols techniques is used on them, results are often control loops has a tendency to oscillate. The reason is that today's valves move by the amount the controller output. This is very little loss in the transmission of the actuation. So moving on, actuator can be done with much less effort. Ziegler-Nichols technique produces a loop that tend to ring like a bell. If the bell is hit at the right time, the bell can get much louder. In the process control, this means the loop will amplify, not attenuate, in certain bands of the cyclic process behavior. In other words, the technique can degrade the process under certain conditions. So basically, if you see that in Ziegler-Nichols technique, when you keep a input, what will happen? There will be one up cycle, then will be one down cycle and another down cycle, another up cycle at least, right? So this is a surge. This is a sudden surge in the output or in the change in the process, right? So this is acceptable in case of the pneumatic system, or I would say rather required. But in the case of the electronic system, this may cause the process to oscillate, which we don't want, and many processes are really critical. So that's why this method is not so suitable for modern day instrumentation. Ziegler-Nichols technique I'm talking about. Again, Ziegler-Nichols technique amplify the cyclic behavior of certain section of the process control, causing degradation of the loop performance. But this is not observed in the direct synthesis method. Now, if you see, Ziegler-Nichols tells us to go to a situation where the quarter wave decay is we can get a quarter wave decay, but where due to this sudden upshoot and downshoot is not acceptable, what to do in that situation, that is not clearly mentioned in the Ziegler-Nichols technique. They have not mentioned what to do if we cannot do this quarter wave decay thing. On the other hand, direct synthesis don't have the overshoot and undershoot problem. So can be used much wider processes. Other things are the relatively easy. The direct synthesis or Ziegler-Nichols is relatively difficult, and speed of response can be set by the user in the case of the direct synthesis method. So you remember the Kc was Kp divided by tau ratio. Now the tau ratio sets the speed of the system, but there is nothing of that kind in Ziegler-Nichols technique. So basically through Ziegler-Nichols technique we cannot change the speed of response of the loop. So that is it. So nowadays direct synthesis methods are getting more and more popularity, and they are getting more widely used compared to Ziegler-Nichols.